Okay, today's lesson is going to be on trapezoids and kites, which are quadrilaterals, but not parallelograms. So our objective is to verify and use properties of trapezoids and kites. The angles, sides, and diagonals of a trapezoid have certain properties, and the angles, sides, and diagonals of a kite also have certain properties. So again, trapezoids and kites are quadrilaterals, but not parallelograms. So first thing you have to know is what a trapezoid is, which is a quadrilateral with exactly one pair of parallel sides. And you have two legs that are opposite and not parallel. You also have base angles. And then you also have a certain type of trapezoid called the isosceles trapezoid, which has exactly one pair of opposite sides parallel and not congruent, and you have one pair of opposite sides that aren't parallel but congruent, and that's the isosceles trapezoid. We're going to get into further detail on the next couple of slides about the different types of trapezoids you can have. So again, a trapezoid is a quadrilateral, one pair of opposite sides parallel and not congruent, one pair of opposite legs that are not parallel. So you have your trapezoid. Remember, arrows indicate parallel. So your trapezoid, you have one pair of opposite sides parallel and not congruent. So our red arrows indicate that those two segments are parallel and they're not congruent. Remember, parallel does not mean congruent. You have two pairs of consecutive angles supplementary. So I know that angle K here and angle T are going to equal 180. So I know K plus T is going to equal 180, and I know U and R. So I have U plus R is also going to equal 180. So those are my consecutive angles, two pairs that are supplementary. All consecutive angles in trapezoids are not supplementary, just two pairs. Well, how do you know what two pairs? Well, they're the pairs that are on the leg. So this is a leg and this is a leg. So the angles on the legs that are consecutive are supplementary. You have legs are not parallel and not congruent. So if you're just talking about a general trapezoid, legs are not parallel and not congruent. So our legs are right here. Remember, top and bottom are bases. So that's a base, that's a base. Opposite angles here are not congruent, and diagonals are not congruent, and diagonals are not bisectors. So just trying to emphasize things that are not happening in a trapezoid. So the main thing you have to know about a trapezoid is one pair of opposite sides that are parallel and not congruent, one pair of opposite sides that are not parallel, and they're called legs. Parallel sides are called bases. Consecutive angles on the legs, supplementary. That's all you really need to know about a trapezoid in general. But then you can also have the right trapezoid. Well, why do we call it a right trapezoid? Because you have two consecutive angles that are exactly congruent. So, same properties of the trapezoid, except that you have one pair of consecutive angles congruent. Okay. So notice that here you have one pair of consecutive angles congruent, okay, and they're also equal to 180. So this is still a leg, and this is still a leg. The legs in the trapezoid, right trapezoid, are not parallel. Top and bottom, or I shouldn't say top and bottom, the sides that are parallel are called bases. Again, diagonals are not congruent, opposite angles not supplementary. Okay, so just remember that these two angles are also equal to 180, I and G. So you have I plus G is equal to 180, and you have R plus H is equal to 180, but just so happens that R is congruent to H because it's a right trapezoid. Then you have the isosceles trapezoid. So again, you have the bases that are parallel. And notice here that the legs are also congruent. Also, with the isosceles trapezoid, you have angle T and R the same. So you have two pairs of consecutive angles supplementary. You have also two pairs of base angles congruent. So two pairs of base angles congruent would be T is equal to R and P is equal to A. So base angle P and base angle A are also congruent. This is only for the isosceles trapezoid. So isosceles trapezoid, you have top base angles congruent, bottom base angles congruent. Still remember that the angles on the legs are supplementary. Bases are parallel, not congruent. Legs are not parallel, but congruent. And in this case, we also have the diagonals. So if I draw on my diagonals, so if I go from P to R, T to A, they are congruent. So T A is equal to P R. Because the diagonals are congruent. They're not bisecting each other, they're congruent. The intersection is not 90 degrees. Okay. So that's the trapezoid. Or I should say the isosceles trapezoid. So here's our mid-segment rule for any trapezoid. You have a mid-segment rule for a triangle. You also have a mid-segment rule for a trapezoid. Any trapezoid could be a trapezoid, isosceles trapezoid, or a right triangle or right trapezoid. This rule applies to all three, where you have your mid-segment, EF, is equal to half times the sum of your bases, okay? Right here, these are your bases. So add up your bases, divide by 2, and that's the length of the mid-segment. Okay. Another way to think about it is 2 times EF equals AD plus BC. And you'll see me use this method quite often. I'd rather multiply the mid-segment by 2 and then set it equal to the sum of the bases. Why? Because since I have a fraction, if I multiply both sides by 2, it eliminates fractions. And we all know we don't like fractions. So just summarizing the rules that I already did, okay? Here's the isosceles trapezoid rules. Isosceles trapezoid rules. So isosceles trapezoid, legs are congruent, top base angles equal, bottom base angles equal, base angles on the legs supplementary, isosceles trapezoid, diagonals congruent, and then you have your mid-segment rule, okay? Or 2 times mn equals TP plus RA. So let's get to some examples. So here I have the isosceles trapezoid. I have angle C. I want the measure of every other angle. Well, you should know that D plus C equals 180. You should know that E plus F will equal 180. And then, so if I know that C is 65, so D plus 65 equals 180, I just subtract 65, and then I get D is equal to 180 minus 65. So 180 minus 65 is 115. So there's D. So D is 115. Well, since it's isosceles, I know that the top base angles are congruent. So then I also know that D and E are the same. And I know that C and F are the same. So 115 is E and 65 is F. So you're going to have to memorize your properties. Next example. Let's zoom in. What's the measures of angles Q, P, and S? Well, I just rotated my trapezoid, which is fine. I can still use my properties of a isosceles trapezoid. How do I know it's isosceles? Well, how do I know it's also a trapezoid? Well, I know it's a trapezoid because 4 sides. I know it's a trapezoid because I only have one pair of parallel sides opposite, and I have one pair of opposite sides congruent that are not parallel. So it's isosceles trapezoid. Well, using our rules of isosceles trapezoid, I know that Q plus R is equal to 180. So if I have Q plus 106 equals to 180, I know that Q, subtract from 180 from both sides, I know that Q is going to be 74. Well, you should also know that this is a base. This is a base. The parallel sides are bases, and the congruent sides are legs, so there's a leg. Well, you should know that the isosceles trapezoid base angles, the top base angles and the bottom base angles are congruent. So S is 106 and this is 74 because R is equal to S, and I know that Q is equal to P only because it's isosceles trapezoid. Let's apply the mid-segment rule. So the mid-segment rule states this, that 2 times the mid-segment is equal to base 1 plus base 2. Well, my mid-segment, it's going to be 2 times QR equals LM plus PN. So substitute in 2 times x plus 2 equals 4x minus 10 plus 8. Distribute 2x plus 4 equals 4x. Negative 10 plus 8 is minus 2. Solve. Minus 2x from both sides. Add 2 to both sides. You have 6 equals 2x, therefore x is equal to 3. So we have solved for the value of x. Now if I wanted the actual lengths, I can plug in 3 plus 2 and get 5. And I can plug in 3 up here and get 12 minus 10, which is 2. And it makes sense because 2 plus 8 is 10, half of 10 is 5, and that's the length of the midsegment. So it's true. So I want the value of x, and then I want the value of mn. Okay. So since I tell you it's a midsegment, okay, and it's a trapezoid, I don't care what type of trapezoid, I can just still apply my midsegment rule for a trapezoid, which is 2 times the midsegment equals base 1 plus base 2. It doesn't matter if base 1 is the top or bottom. It's going to be your choice. Base 2. So I have 2 times my midsegment is mn. Base 1 is qr plus ps. So 2 times 2x plus 11 equals 10 plus 8x minus 12. Distribute, so we have 4x plus 22 equals 10 minus 12 is negative 2 plus 8x. Subtract 4x from both sides. Add 2 to both sides. I have 24 equals 4x. Divide by 4. Get x equals to 6. But again, so I know x is equals to 6. I want mn, so I substitute in. So if I have mn equals 2x plus 11, 2 times 6 plus 11, I have 12 plus 11, so mn is equal to 23. So let's go into our kite properties. So a kite is a quadrilateral with 2 pairs of consecutive sides congruent and no opposite sides congruent, and no parallel sides. So a kite is a quadrilateral, not a parallelogram, with 2 adjacent sides congruent or I should say two pairs of adjacent sides congruent, and no sides parallel. So diagonals of a kite are perpendicular to each other, so I have that in here. One diagonal bisects the other, indicating that right here I have A, B, C, D. CD bisects AB. One diagonal is an angle bisector, so the angle bisector is CD. So I know that those angles are congruent of C, and I know that those angles of part D are equal. I have one pair of opposite angles congruent, and this is going to be B and A are equal. I have no parallel sides, and I have two pairs of adjacent sides congruent. So notice that I have tick marks. So those are adjacent. Adjacent means next to. They're congruent. Then I have congruent again. Congruent doesn't mean parallel. So here there's no sides parallel. Other things you should be aware of with a kite: that you will have two congruent triangles. You should know that triangle CAD is the same as triangle CBD. So those two triangles, the triangle up top and the triangle down below, they're congruent. Other things you should know: that this angle right here with A is the same as this angle right here with B. And this angle right here with 4 is the same as this angle right here. So those angles are the same. Why? Because you should know that triangle 1 and triangle 2 are the same. So triangle 1 and triangle 2 are the same. And then you have triangle 3 is the same as triangle 4. So there's a lot going on in the kite that you're going to have to remember. The main things are down below here. Diagonals of a kite are perpendicular. You have one diagonal that's a bisector of the other. You have one diagonal that's an angle bisector. And you have one pair of opposite angles congruent. So angle B and angle A are congruent. No parallel sides, and two pairs of adjacent sides congruent. So you have a quadrilateral. It's a kite. It's not a parallelogram. I want to know the measures of angles 1, 2, and 3. Well, first of all, if it's a kite, I know that these are congruent. These adjacent sides are congruent. I also know that the 90 degrees is the intersection of the two diagonals. So angle 1 is 90. How do I know that? Because diagonals are perpendicular in a kite. So this is 90 degrees. So you have to forget, or don't forget, that you have a triangle. So you have 90 plus 52 plus angle 2 equals 180. So angle 2 is equal to 38. Don't forget your triangle rules. And angle 3 is equal to 52. How do I know angle 3 is 52? Let me erase this. Well, don't forget that I said that triangle 1 here and triangle 2, they're the same triangles. So if they're congruent triangles, that means their corresponding parts are congruent. So if angle 2 is here, I know angle 2 is here. And if I know angle 1 is 90, I know this angle is also 90. And if this is 52, that's 52. So if triangles are congruent, corresponding parts are also congruent. So let's try another one. So I have a quadrilateral, it's a kite. What are the measures of angles 1, 2, and 3? Well, I already know angle 1 is 90. How do I know? Because the intersection of diagonals is 90 degrees. So this is 90 degrees. Let's change up my color. So also I know I have this triangle highlighting in red. So I'm going to redraw it. So if this is 36 and this is 90, I can get this angle. Because how many degrees in a triangle? 180. So this angle that's not marked, well, it's N. I know that angle N is going to be 90 minus 36, which is 54. So this is 54. Again, honors geometry, you're going to have to find angles that aren't labeled. So this is 54. So using your rules of congruent triangles, I know that these two triangles, okay, triangle 1, triangle 2, they're congruent. So if they're congruent, I also know angle 2 is equal to 54. And I know that angle 3 is equal to 36. How do I know that? Again, the two triangles are congruent, therefore corresponding parts are congruent. So to summary on what we've been doing in the last 2 weeks is we've been studying quadrilaterals, okay, which is polygons. So you should know the quadrilateral is 4 sides. Well, we just studied parallelograms. We just had a quiz on all these shapes over here. So you should be familiar with parallelogram and their properties, rectangle and their properties, rhombus and their properties, and square and their property. So this little flowchart tells you that a square is a rectangle, a rhombus, a parallelogram, and a quadrilateral. A rectangle is a parallelogram and a quadrilateral. A rhombus is a parallelogram quadrilateral. That's it. And a parallelogram is only just a quadrilateral, which is a polygon. Then you have trapezoid, isosceles trapezoid, and then don't forget about the right trapezoid. And then you have kite. So these are all special types of quadrilaterals that you need to know and their properties. So here are some example problems I'd like you to try on your own. These are very good challenge problems. And then also try the homework. If you have any questions, see me after school, before school, send me an email, and also work on your Math Excel.